First of all, like you tell me what are the things that you have gone through. Like I have given you the study list, right?
Yeah.
Yeah, so tell me like what are the things that you have gone through till now? Like the what are the projects that you have run? Like they have given you some these things. So I just want to know your understanding.
I completed the first of all Verilog,
Okay. Hmm.
basics of Verilog. Then I ran some projects like your the
Hmm.
logic gates are there, and some of your sequential circuits and some combinational circuits also.
Hmm.
It includes half adder, full adder,
Okay. Hmm.
then all logic gates, AND gate, OR gates, everything.
So you are comfortable with digital design, right? This half adder, full adder circuits, sequential, these things.
Yeah,
Okay.
yeah,
Okay. So you have,
yeah.
huh,
I understand the code actually,
okay,
uh, f- uh, which I already practiced, but the advanced one I am not sure.
okay, okay. So you know this coding of this Verilog and the for let's say example half adder, full adder code you understand, right?
Yeah,
Okay. So you know about test bench like in Verilog also we have one design file that is .v and
yeah.
yeah .v file and there also we can write a test bench file. So do you understand what why do we need the test bench?
Yes, statements are basically uh, help to input the values and
Haha.
verifying the outputs are desired outputs are getting or not on output is getting or not.
Okay. Huh, huh. Hmm. Okay. So, so you understand test bench also, like its requirement, why we need test bench. So, Verilog, you like you are comfortable. So, system Verilog, you have gone through anything?
Uh, I first I see, but I can't. I don't understand that.
Okay. Oh, okay, okay. So, if you are not able to understand, like, what are the things that you are not able to understand as compared to Verilog? Like, what it's not able to understand at all.
Um, actually, I see the Verilog the more.
Hmm.
First of all, I see the what kind.
You have seen any coding
I
example for system Verilog?
I all I only gone through the theory also
Hmm.
theory.
Huh.
So
Okay. Hmm. Okay, so and then so let's say I'll just quickly go through your system Verilog, okay? So
yeah,
system Verilog has so many things are there. I'm just giving an overview. So if you go through the system Verilog, it will be just the enhancement of Verilog. So test bench file that you have seen in the Verilog, the same thing can be designed with the improved version of the coding, basic coding if you know, like this concept of a class and everything, class randomization, those things will be available in system Verilog. Okay, so
yeah.
it's like more uh, so it's like an enhancement for Verilog. So system Verilog, if you go for basics, like you search for the internet, system Verilog, free search, if you search, you will get some website, or you can go for, so see it's saying the classes is inheritance, polymorphism, randomization. So this randomization is very important. So let's say you have one full adder design. So there you need to provide some values, but every time you cannot go for, let's say 10,000 possible values are there. So you cannot give like 10,000 possible values and run the code. So for that randomization you will do, like let's say any values between 1 to 1000 will come. Okay. So in that, so these are the features that you can use. One is more advanced, is like assertions. Assertions you will get to learn about more when you do this assertion based verification, or you can say formal verification they call. Yeah, and these are like the mostly like interfaces. This package something mostly this object oriented programming. If you have uh, studied in your coding some subjects, so ops you will learn. So those things are available in SystemVerilog, not in the Verilog, okay? Because Verilog is only for hardware design. So everything you write in Verilogs that like should be mostly able to synthesize, okay? The means hardware can be generated from this coding. But SystemVerilog, like let's say forever loop, those kind of things cannot be uh, synthesized. So these are the things. So if you so okay, so that's the main thing. So first, like you go through the SystemVerilog few test benches you have to go through. I think I have shared you some files, right? Like did I share you for SV?
SST.
Yeah, SV. Yeah, SystemVerilog some projects that I shared you or not? Like
No. System Verilog is not set, I guess.
okay. Then I will share some GitHub links there. Like this, all the files will be there. You just try to understand each purpose of the files. Then you try to simulate it. Either you can go for some online simulation or Vivado that we have. That also you can do. Okay.
Okay.
Hmm. Then next coming to UVM. So UVM, you have gone through anything?
Universal verification methodology.
Yeah, yeah. So what are the things that you have like gone through anything that in UVM?
Uh,
Your
Theory.
audio is not coming properly.
Yeah, I studied design, the architecture
Okay.
where test environment,
Uh-huh.
agent sequence driver motions are there,
Hmm.
and but I only only studied theory part.
Okay. Okay. So you have gone through this UVM. Okay, I will share quickly. Just you can just see. UVM enter screen. Okay. Screen. Can you are you able to see my screen?
Yes.
Okay. It's not like this. So like the things that you said, na, this overall test bench will be there, then environments, then agents, then driver monitor. So these things, see, so we already have as a system, I mean, SV as a verification methodology, but why do we still need the UVM? Okay. So first of all, like this EVM is for universal verification methodology, means all the companies, let's say there are some other many companies like ABC. So those earlier it was like every company has their own different kind of verification architecture. So it is difficult, like a person is switching companies from one company to another, then he has to understand like the whole architecture again of the verification plan. So later they developed the UVM, universal, means everyone can like implement this. So it's for every company will like follow this. It's like the universal. So there mostly they have the architecture for the purpose of verification. So how you will verify your design? Let's say this is duty, you can see duty for design under test. Okay, so here what will be your duty in your full other, let's say not full other, FIFO, let's say we say FIFO. So this is the FIFO design that you will do in Verilog. So this will be your duty, okay? Rest other it is the interface is there. It will be like connection of the signals from to your duty to your test bench and then test. Then here under you will see driver, monitor, and scoreboard. Okay, these are the like three main things that you will be seeing. So driver will be like, let's say there is a FIFO, you need to drive some signals, let's say the data input address or something. So these things can be driven by your driver. Okay, and monitor means it will just monitor the signals, like what are the signals that you are driving. Then in the scoreboard they will try to compare whether these this is, let's say, write and read you are doing. So one side write, one side read. Let's just an example I'm giving you. So based on that, like FIFO, is there any data corrupt or something, like any mismatch are there? So those can be verified in the scoreboard. So you understand like why do we need UVM, or like
Yes, it is basically universal for all organization or company. That's why.
okay, that's one thing. Like main purpose of UVM, like why do we need like verification? First of all, do you understand why do you do the verification?
Verification is need because uh, we need to verify the circuit is actually working on or hardware is actually working or not.
Okay. Okay. Yeah. So like verifying. I mean, this just the design is there. This behavioral design. So just the design is there any bugs or something? Like in some corner cases, let's say, some bugs will be there. You will understand like what are the bugs like in the design. So these things. Let's say I have already. I'm still we are working in this project, right? So APBXI. So let's
Yes,
here if you see. So we will see like okay. I'll just see. So these are the transactions that we are able to see the screen.
yes,
Okay. So these are the transactions that is happening. But if you see after some point, only till here, let's say this is what 13 nanosecond or something. Till here on few, okay, 16 nanosecond or something, the transaction happen. After that, there is no transaction that is happening. So there's something going wrong. Okay. Either it could be a verification error, or I mean, the UVM test bench error, or maybe it's a bug in the design. Okay. So we have to just debug it, like to find out what's the issue there. And based on that, we have to either modify the design. So we have, let's say there will be some team that is working in the design of the modules, or the actual the design, who is designing that. And then there will be a verification team, so they will try to run the simulations in like clock will be there, reset will be there. Then architecture that we have for both design and verification, people will follow. Okay. And then if there is any error in the design, so they will report it to the design team, and they will fix, and again then this will get to the verification team. So this how this cycle works. For your understanding, I will share you some detailed PPT or something, or YouTube lectures. For first you go through the system Verilog, okay. Then all the basic you clear. Then the UVM also I will share the same thing. Then I will give you some projects, like 1-2 APB project or something that you will do, and then try to understand the code and then run it. Then see like how it's going. Okay. Yeah. So this way will be like able to do.
I have a question.
Hmm.
Uh, is the syntax of the Verilog and system Verilog are same or different?
System syntax for Verilog and SystemVerilog are enhancement, means it will be same. Verilog will be same for SystemVerilog, but there will be some extra things that will be added in the SystemVerilog that will be not be in your Verilog. Okay. Syntax wise, it will be can you say no? It will be different. Enhancement means different things will be there as compared to Verilog. It's not like the syntax is going different. I mean, don't worry about the syntax right now. It's just you're able to understand basic like coding things only, not maths. You can right now ChatGPT is there now, so if you have any doubt, you just paste the code or something. Even it will be able to generate everything from now. Any other doubts do you have? Like,
Uh, now, I have some protocols like AMBA protocols and
protocols also I'll tell. Okay, so what do you understand by protocols first of all?
protocols are that is used to communicate between the hardware devices
Okay,
like
Basic,
HDMI,
uh-huh. So they
like
have,
HDMI. Yeah.
yeah. So I mean, mostly for some communication protocols that we have, like AMBA. This AMBA is coming, AXI is coming under AMBA. Okay, so different like communication. There will be some devices, let's say memory device or something, CPU, GPU. So those kind of device need to communicate, right? Like data transfer between registers and your CPU. If you study the computer architecture course, this one also course you study, okay, it is in your B.Tech. Have you gone through it till now?
Yeah, little bit in microprocessor ideas, I guess.
Try to get this course in your B.Tech, okay, either from NPTEL or something. This one is quite important. I mean, if you are going for verification also, it's quite important for if you want to be good in your verification. So computer architecture, the cache memory or these things, the how the GPU computer architecture, these things you should be. If you know these things, then it will be much more understandable your protocols or something. So protocols, like if you search like these are the communication protocols or rules that you can say. So they have mentioned some rules. Let's say for if you go for the APB, just so APB protocol. APB protocol is the, I mean, very basic one, okay, to start with. So uh, so this is a state machine diagram for APB. These are the signals that we have, and the one waveform diagram will be there. Okay, this one. So so see, I will was first will go through the signals. Okay, so this is a APB master slave configuration. Okay, master slave means maybe one is maybe requesting you something, let's say some data or something, or one is like giving you that. So master will be requesting some data from slave, and slave will provide that. Okay, so it's basically a read transaction. Write means master wants to write some data in the slave. Say slave, you can understand if you go in some architecture, then you will see where the APBs are connected, and then where the PCI and AXI. Okay, there is a document from ARM that you can go PCI and PCI and AXI connection. Uh, one zip. So URT keypad bridge. PCI device. So these like this is just an sample they are showing. So between these devices, let's say this is DRAM, they are connecting the AXI, PCI. So for the communication of between these, so we'll have this AXI. So you can see here, right? Yeah, then PCI will have. So if you go, first of all, if you go for the APB, so you will see the signal P clock, P reset, then P write, then address, then data, then P ADR or something. These are the signals that we have, and then wait, and so this is a write transfer without wait state. So this is the waveform that we will get, where clock will be there. Then you will assign address, then P write, then you will assign P select. Then P enable should be high after one clock cycle of the enable the P select. These are the rules that we will say. Everything has their own rules. Okay. Then PW data and P ready. Once the ready is there, means this ready will come, like you need to understand from where ready will come, from where you will get this ready signal. So Once ready is high means data transfer is completed in the next cycle. So in the T3, after T3 you will see the transaction happen. So if you go through it, you will be able to understand. Okay. Till now it's clear, or do you have any question?
Yes. For now, it's clear.
Okay. So this way only you will have to go through. Okay.
Okay.
So this is APB. Now if you go for AXI also, just a minute.
XI is advanced version of APB, I guess.
No, these are different protocols. Just a minute, I'm just coming. Yeah. Hello. 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 सुन रही है? Hello.
Hello.
Yeah. So no, AXI and APB are different. APB, this is like very low power communication protocol. AXI is very high advanced. Okay, it's like very high speed, and so many features are there in it as compared to AXI. So you should, I mean, you understand first AXI, then APB, then AXI, then there will be some difference. This in interview, if you go for some design interview, they will mostly ask you about what are the difference between AXI and APB. Okay.
Okay.
Yeah. So first you should know like APB theory, everything. Then AXI, then try to get the basic difference between AXI and APB. Then AXI protocol, if you search, so you will get something like uh, mostly the differences, like what are the channels that is available in, if you go for this here it will be available. So in AXI, if you APB, if you see now, so all the signals that are there, like write, read, so there will be one read transfer and write transfer. Okay. So here, as like only we have the same signal that is getting used for write and read. So write and read can be done like one after another. Okay. This cannot be parallel. Let's say you are not able to read and write at the same time. So that's one, I mean, you can say limitation of APB. If you go to the AXI, so they will have like 5 channels. Okay. Channels you can understand, like read channel will be there, then write channel, then response. So here if you see, one for total 5 channels are there in AXI. Okay. One will be AW address channel, one will be for write channel data, and then one for response. And for read, we have only two, because if the read data is coming, the response will come along with that. Means we're getting the read data, means response will get. So only two is required. Okay. So how the communication happens, like first this is AXI master side is there, then slave. AXI will first initiate the uh, write address, it will give, then it will give data, then it will wait for the response from the slave side. If the response is okay, then the one write transaction is complete. And then for read, like it will give you the address that it wants to read, then the data will come, then the transaction is complete. So if you this is just like two communication. Here will be so many signals will be there in AXI. So if you go for AW size will be there, AW address. This is the right address, all the channels like AW valid, AW ready. Valid ready protocol you should you understand, okay? Like how the valid ready protocols works. And then for data also we have W valid, W last means last. data for the transaction. In this, then you can you should be going through this burst kind of transaction, water burst transaction, and all these things. And then these are the waveforms that they are like simulation they have done. This is a waveform. This is also done in Vivado, so you'll see like this kind of waveform in Vivado. Vivado is a open source, like for limited this features you can go through. Okay.
Uh, in Vivado,
Hmm.
I see one thing that
Hmm.
it only gives the certain range of waveform. After that, it does not show why it is happening. I don't
Certain
understand.
range means some timing you are asking, like number of
Which I have to input on the code or something.
not able to, I mean, what's the problem?
In Vivado, when we run a code
Uh,
in waveform, it only gives the waveform or output in the certain range of data. After that, is the waveform is straight line or something.
okay, so it's like something straight is you are asking, saying.
Suppose we do for the OR gate, AND gate.
Uh,
Suppose we are running a code which is R for OR and AND gate,
uh,
then it only gives the output in a certain range of data. After that, the output is straight line or
okay, maybe you are running only till some point, then it will be straight line only. If you are, let's say your transactions are complete, then after that you can see the nanosecond time frame. Okay, so how much time you are giving for each transaction, and if it is getting completed like you're within the time frame, then it will be straight line, you can say. Or like just see that whatever in the test bench how many transaction that you are giving, if these are going through, then it's fine. Otherwise, like, or you can share me this share me, then I'll just go through. Okay.
You can set the time. See on top of the screen, beside the blue run button, there is a time mentioned. For now, it is 10 microsecond. Can you see on top of the waveform?
which I have to input on the code or it is
No, see
pre.
on top of the waveform, can you see a timing 10 microsecond?
Yeah, yeah.
Yeah, so based on that, it will implement till whatever time you have given there. So you can increase the time there and check if it is um, giving you the correct data after wherever it is coming straight line. Yeah.
Any other doubts or something you have?
Till now, no.
Okay, you just go through the theory. Okay, I think I shared you this YouTube video links. I'll just check once if this is fine. Then just few YouTube channels are there for XI. Till now you have cleared of Verilog, right? So you can next move to the uh, system Verilog, then UVM. Okay. Yeah. Okay then. Hello.
Hello.
Yeah. Okay. You can like if there is nothing, you can drop off. Okay.